Did you ever wonder how AI models just suddenly evolved from doing simple tasks like spam detection and autocomplete to all of a sudden writing code and passing law school exams? Traditional neural networks, like recurrent neural networks or RNNs, would read text sequentially, so one word at a time. If they wanted to do a task like translation, they would have to read the sequence of text into an encoded state of fixed length, and then decode that state back out word by word. However, complex sentences often contain long-range dependencies between words, and RNNs would struggle to maintain that long-range context, and so it would lead to translation errors or just incoherent output. Now, to address this problem, a 2014 paper proposed a concept of attention, which allows a model to consider all of its encoder hidden states while it's decoding. Now, this enables a model to focus on all of the relevant parts of the input sequence at each step. You can think of attention like a spotlight that allows the model to consider which parts of the input sequence were most relevant rather than just treating all the words equally. And then a few years later, in 2017, a new paper titled "Attention is All You Need" proposes a transformer architecture, which is the T in ChatGPT. And they claim that with attention, you eliminate the need for recurrence altogether. And this architectural paradigm shift that came with these transformers meant that sequences could now be processed in parallel, massively improving computational scalability. Self-attention allowed each word in a sentence to interact with every other word, allowing us to capture context and meaning like we never could before. And it was these key breakthroughs that allowed large language models like GPT to finally generate outputs that were coherent and contextually meaningful. In my previous video, I talked about tokenization and embedding, but in my next video, I want to explore how self-attention works under the hood and explore its mechanisms step by step.